So basically, I'm going to do this in two ways now. So we have this. So this particular question is actually it's not bad. It's actually very simple. So what what you just need to understand, get is just a formula because if you are to do it the raw way, the raw format, we are going to spend a very long while trying to get our head across this. So what I'm going to I'll just give you the formula now. But the formula will be in two forms. So the first one is M1 over M2 is equals to chemical equivalent 1 over chemical equivalent 2. Some people call it electrochemical equivalent. So, but this is the first formula. Then the second formula will now be, let me use another color so that you can remove it or not. Then cost 1 over cost 2. So this is it. So we have this formula. So it is only when it comes to like they are saying, if it costs 1 naira to discharge so amount of so mass or amount of aluminium using kilogram. So how much will it cost? That's when the cost comes in. But in this case, we are not going to use the cost part of it. So that's the logic. So that means this is the only thing we need to use. So that means you need to understand some concepts here, something like chemical equivalent CE. So chemical equivalent basically, don't forget, first Faraday law of electrolysis states that uh, the mass of a substance discharged during electrolysis is directly proportional to the amount of to the quantity of electricity, that's Q, that passes through the electrolyte. Then you now say, okay, M equals to what? A constant. The constant is now ZQ. So this Z is the what? Chemical equivalent. That's the logic. Chemical equivalent. So the chemical equivalent here is what? If you have to define chemical equivalent, that means Z equals to what? M over Q. So when you say, okay, what is chemical equivalent? You can say chemical equivalent is the what? The mass discharged by a unit quantity of electricity, like by just 1 coulomb. This key here, the unit is coulomb. So the mass of a substance discharged by just 1 coulomb is what? Is Z. So that's one thing to have in mind. And let's say, for example, they say calculate you want to get the Z. It's a constant. You want to calculate the Z for a particular substance. You can do that. So you want to calculate the Z for a particular substance. You can basically do that easily. So and what do you do? What do you do on that? So it's just let's say for example I want to get our Z. So this is it. Let's say I want to get the Z for magnesium. This thing might be kind of tricky, sha. So but don't forget, magnesium basically might be 2 plus. Don't forget, if it's in the electrolyte, it will be in the ion form. So when it is now discharged, it will need to get 2 electrons. Have you now? To now become Mg. Have you now? And I told you in the previous slide that 2 electron is equivalent to 2 Faradays. 2 electrons is equivalent to 2 Faradays, and 2 Faradays is what? 2 times 96500. That means 2 Faradays is needed for me to discharge what? Just 1 mole of Mg. Just 1 mole of Mg. Have you now? And 1 mole of Mg is how many mass? 24 grams. Have you now? So that means 24 grams of Mg will be discharged by 2 Faradays. Have you now? And that will give me the what? The Z. So the mass over Q. So the Q here is what? 2 Faradays. So 24 divided by 96500 times 2. That is like 12 divided by 96500 will give me the Z for what? The Z for magnesium. That means coming back to this now, this CE we have here, you can change it to Z. Let me even do that now. So I can say Z1 over Z2. Z1, sorry, let me use the color so that you won't be thinking Z1 over Z2. So that's the logic here now. So, but once okay, just so that you will not be wasting your time or something. So don't forget from what we just did here, you notice that how do I got my Z? The molar mass of the guy divided by the charge it has on it times Faraday. Abina. That means if I want to get for don't forget in this case now we have copper and aluminum. Let's say copper is 1, aluminum is 2. That means the Z1 for copper will be what? Molar mass of copper, which is 64 divided by the charge of copper, which is 2 times Faraday. Abi now? Then divided by that of aluminium. Aluminium is 27 divided by the charge on aluminium is 3 times Faraday. What do you notice? Faraday can still cancel Faraday. So that means in this formula alone, shey you get, in this formula alone, you can use your Z as just molar mass over charge. Let me just explain that to you. So, and if you understand that part now, we can now go ahead to now doing our work. So I would say copper should be 1, aluminium should be 2. So if you now have that, so they said this is not molar mass, this is mass. It should be like small letter m sharp or less more. So that's mass. Now saying two electronic cells are connected in series. If they are connected in series, what does that mean? They have the same current throughout. If they are connected in parallel, different current but the same voltage. That's the electricity is thing. Series means the same current but different voltage. This is series connection. So you have the same current that will pass through them. And if it is the same time, don't forget it's not even about if it is. As I'm teaching you are also learning them, we are using the same time. Sure you get. So at that time the whole cells, the all these guys will be using the same time. It's cell, not so it's something like this. You know how cells have been connected. So something like this. So if they are in series, you have the same current and different what? Voltage. That's logic. So they said the same quantity of electricity. This formula only applies if it's the same quantity of electricity, both the cost and the one without cost. So, so okay, so now I have these two guys. So you don't need to bother yourself about the anion there or the radical that we have there. Don't bother yourself. Just take note of aluminum. You know, aluminum is always aluminum 3 plus, but copper can be copper 1. So, and if it is copper 1, the charge is not be Cu plus, not Cu2 plus. There's a trap around that, and I set it a lot, a lot. Yeah, a whole lot. I'll drop a question. Okay, let me. How many hours do we have more? Okay, we still have more than enough time. So let me. If I not do it now, I'll forget. So I think it's forms. Do okay. Okay, docs. Okay, yeah, this is. I hope I'm able to see it very fast. I'll just drop the link to the quiz directly on the group now. Okay, so I think I can see the name of the business more small. There is one on electrolysis, and I'm very sure, no way that I will not put it there. Ah, that cannot be electrolysis. This is transport system. Yes. This is the first set of quiz before we have our website. So this is what we use. So this is like organic. So the thing remember up. How can I see it like this? So coming. Okay, so I hope you guys are also saying this. So from here now, so we already have this. So my point out of this is that okay, make sure like you take note of just they say copper 2 sulfate, you can say copper 1 sulfate. So that's if the mass of copper now is what 8.48 and copper is 1, so 8.48 divided by what's M2. We are looking for the mass of aluminum. Okay, they said it is this, so we can just look for it sharp, or we can do okay, let's just look for it. It's equal to, I'll put X here. Don't worry, it's a true or false question. So that's why we have 7.2 gram as the answer here already. So then Z1 now, for copper, it is 64 over 2. Abi now, remember that. Although you are still supposed to divide by the Faraday's constant for a normal electrochemical equivalent. But in this way, because the Faraday here will cancel the Faraday here, that's why we are not using that. So you have 64 over 2, that will be what, 32. Then divided by what? 27 over 3, which is 9. So if we should divide that, let me, don't forget you have to work with our calculator, but I don't have that time. Or most of the time, they won't be giving you 0.48, or they won't be giving you something that you cannot divide in posterior what you are doing. If they will not give you calculator, so just trust them. But even if they not give you, you should be able to work it out, like to some extent. In a way such that you can try to reduce this one to 8.4 something to, and then divide this guy by the same thing then. But just because of time, calculator. So we have 32 divided by what? 9. You have 3.55 times, most likely to be wrong, sha. Most likely to be wrong, shey you get. But the answer should be false. Let's see what we have there. The answer will be, yeah, it's false. Let me show you. Do you see that they said the answer is 2.4 grams? So let's see if your answer is 2.4 grams. So the answer is 2.4 grams. Let's check. So you have 3.55 as this. We are looking for x. That means that we got 8.44 divided 8.4 divided by 3.55. 8.48 divided by 3.55555555555. So the answer is 2.38 here. Is that what we saw here? 2.4, yeah, that's it. So this is 2.4, but the answer I got on my phone here is 2.385, which is still 2.4. So that's actually now valid that this thing is wrong. So that's just the logic. So basically the answer for this one is false. So let me quickly